Great, ladies and gentlemen, all EGD colleagues. Yes, this is the memo discussion. This memo discussion is specifically focused on paper 2 of September 2021. This memo discussion will, to a great extent, give you the insights and also the knowledge on how exactly it works when we mark national senior certificate exams. Of course, we haven't got dummy scripts and we haven't got control sheets and all those type of things and so on. So yeah, we will get there at some stage. But at this point, I would like you to show you how the examiner at the National Senior Certificate exam is thinking on how he should approach some of the drawings itself. All right, so let's follow away. I've got here on the screen the following information. We have done paper 1, so therefore I'm done with paper 1, which is this paper over here. So there we go with that part. Then if we go to paper 2, this is paper 2. On this page over here, it points out to you that it will be third angle graphic projection, that we all know, mechanical analytical. So that will be more or less 15%, loci of cam and loci of mechanism 20%. In this specific paper, the loci of the cam was the question, so it was focused on this part over here. And then on the isometric drawing, that is also part of the isometric drawing information that I will show you now more information on. And then mechanical assembly. Now that is the mechanical assembly if we focus on that part. All right, ladies and gentlemen, then this will be basically exactly the same, with the exception of the rule that the examiner can go ask mechanisms as a question. He can also combine the two questions, cams as well as mechanism. How will he do that? And most probably he will be pointing out to you a cam displacement graph on the one end, and then roll over to a mechanism as a second option of the question itself. All right, so and that will be more or less 20%, so that gives you, give and take, 40 marks, 38 marks there in that vicinity. All right, so this is your percentages, more or less 30 marks for mechanical analytical, more or less 40 marks for cams alone, or cams and mechanisms combined, or mechanisms alone, and then also your isometric drawing, that will be 40 marks, and then about the vicinity of 90 marks for mechanical assembly drawing. Okay, so this is what I want to say to you about this exam. Then the next I want to point out to you is, according to the National Protocol of Engineering, Graphics and Design, the examination guidelines. According to the guidelines, we have to be able to do the following in terms of the drawings itself. Let me just quickly page down now to my page. That is perspective, and it starts here with mechanical drawing. It will be third angle graphic projection at all times in question 1. All right. It will be sectional and non-sectional drawings. It will be half sectioned. It will be partly sectioned. It will be complex mechanical assemblies. All right. And then also the title scale, layout and planning of center. The planning, ladies and gentlemen, in this specific paper of September 2021, I pointed out to you that the starting position of most of the drawings was given. Remember, I want to test the learners in terms of their ability. Now, one of the skills that the learners should have also is to plan and to put and place the front view and left view, or front view and right view, in such a way that the learner will be guided or helped in the process to get to the start position. So therefore, the learner should do that himself. All right, so that's the layout and planning. And then, of course, hidden detail might be asked. All right, and then the cutting plane should be in there, the hatching detail, the dimension, not very quite, but yes, I will show you some information about dimensions just now. And then also the notes and the symbols of projection. That is basically important. All right, I will show to you more about that. And then also hexagonal bolts and nuts, washers. The size of washers is important. Spacers, and then keys and keyways will all be relevant. And then also the different types of sectioning, in other words, aligned section, revolved section, removed section, offset, and then also successive sectioning. Those are some of the examples. The learners should know those different options of sections. And then also conventional presentation of common features, and then also the format and content work drawings and title blocks, and then also the detailed drawings of individual components itself, especially for that one with grip screws and those type of things and so on, which is basically coming from nuts and bolts. And then also the basic welding symbols, mechanical symbols, treatment symbols, and then also tolerances. That is important over there. All right. This is all, of course, comes from the SANS guidelines, and then also all constructions must be visible, and if it's required, you have to show the construction, and then also the same with that hidden detail is also required. Not often with isometric drawings, but yes. Question 1 includes all the above mentioned, and then also the primary focus of question 1 will be the prescribed content of mechanical drawings, aspects of paper 2 topics, in other words, the SANS principles that need to be applied into this part of the year. And then question 4 will be multi-views question, all right, 1 or 2 multi-views, and it can also be more questions on the same topic itself. So it's not to say it's only one assembled drawing that you can get. All right, loci of CAMs, ladies and gentlemen, we will focus on complex applications of CAMs. All right, and then the CAM follower detail, whether if it's wedge shape or roller, and then also the displacement graph that needs to be placed over there. I will talk to you about that just now. And then also the CAM profile of the CAM plate itself. And then the motion can be uniform motion, it can be simple harmonic motion, and it can be also uniform acceleration and retardation. Those are the 3 options. And I often see learners struggle with the other 2 options, and it's actually not too difficult in doing so. All right, so yes, please let's focus on that for the last attempt for making the learners aware of those things. And then also the direction can be clockwise or anti-clockwise. If it's clockwise, you number anti-clockwise. If it's anti-clockwise, you number clockwise. And then also the follower may be placed at any angle. 90 degrees, horizontal, 30 degrees, 60 degrees, it doesn't matter. 270 degrees, it doesn't matter. All right, and it reciprocates, in other words, goes up and down on that one, or left and right to left, or whatever the angle might be. And then also the follower may be wedge shape or roller. Those are the different types of followers that we can get. Loci of mechanisms, I want to point out to you this point over here, there might be 3 different options of mechanisms that can be asked. All right, and then also constructions must be shown, and it will be only irregular curves will be generated from this part over here. Then the isometric drawings, remember, low order will be non-isometric lines with auxiliary views. Middle order will be circles, and then the high order will be then the section of an isometric drawing itself. All right. Required auxiliary views must be shown. You can't just rub it out afterwards. And then also hidden detail normally is not required, but yes, it can be required in the process. All right. And then also accuracy is very possible, very important. Sorry for that. And then also it's permissible to have only 1 millimeter deviation, or 1 degree if it's an angles deviation in terms of that. All right, and ladies and gentlemen, the last thing I want to point out, if a learner draws something in freehand, you will not get the marks for that, especially for paper 2. For paper 1, hatching of substructure is still allowed, but for the rest it is not. All right, so ladies and gentlemen, this is out there. This is your question paper. I want to focus more on a few things before we start. Now, with any engineering, graphics and design exam paper, the following will apply. And actually, this is also for paper 1. I've done some of this during paper 1, but this is basically focusing on paper 2 now. So let's focus on paper 2. Yes, this one I also said with the memo discussion of paper 1. Treat each learner fair. It often happens that the learner, that you know the learner, and the learner is always giving you trouble at school. My point is, please ignore that. Try to ignore the names on the right and bottom side for that moment when you answer your question. First, go through the answer sheet of the learner, and then if it's really up to the points up to the end of the exam paper, then you start focusing on the learner's numbers and so on, and the names. And then also you calculate and everything 100% correct in terms of that. All right, so yes, fair. And then also in a rush through the scripts, it often happens that you make mistakes. So please don't be in a hesitating mode and trying to fix off the exam papers as quick as possible. Spend time on accuracy. And then also, besides that, if you start tomorrow with the next question, make sure go through the question, go through the answer sheet, go through the memorandum every time when you break, every time when you come back to the answer sheet and start marking again. Just familiarize yourself with the answer sheet, and then also be fair at all time. The principle of marking with the mistake is always important when you mark in engineering, graphics, and design. I will show you some options in a few moments from now, but yes, that is what I want to point out to you in terms of that. All right, and then also read through the memorandum, like I said, and refresh your memory every now and then. Mark from the marking guideline at all times to ensure consistent marking. All right, so in other words, if you pick up something, rather phone me or the other subject advisors in terms of making sure that you are on the right track. If you are not sure, making sure by your subject advisor, and ask him for some advice in that regard. All right. Then the next I want to point out to you is check the sequence of the scripts against the examination numbers and the mark sheets. All right. So that is for national exams. That is before you will also enter your marks onto your mark sheet. Make sure that the scripts are in the correct order to help you not to mix up some of the marks in the process. Right, and then also check whether the candidate marks was absent or not. And if it was absent, it will be on SANS, it will be a -1. And then also ticks will look at as follow. This is for a right tick, for a full mark, for a half a mark. It will be a tick with a small little tail, or it will be an upside down V. And then if something is wrong, obviously we will go back to the conventional cross. All right. Your moderator at your school, your co-teachers or colleagues, and then also the HOD at your school should mark in a green pen. You will keep on with the red pen, and then so. And then also each marker have a DBE signed off scale 1-to-1 memorandum. All right, I will get to that just now. I will just point out to you that's not a DBE one. This is a Department of Provincial Education. So therefore, that is what I've sent. I will send out just after this session, and will provide you with the information itself. All right. Then also DBE signed off. The transparencies. If it goes to the transparencies again, this is not DBE. It's of course the memorandums that you will work from. Transparency. Can maybe show you on the screen just now. If you should take a look at maybe a question paper like this one over here, ladies and gentlemen, what we say about a transparency. If we talk about a transparency, this is a transparency made from the correct, of course, memorandum. This is now the memorandum. So what I did is, you can't just put any transparency, please. You must make sure that this is a transparency for copying. So make sure about this. Then if you make this before you start, and I will make it, say for instance from this drawing over here. So before you start with your memorandum, before you make your copies, make sure that if the examiner said that distance from there to there, for instance, is 25 millimeters, make sure that if you copy this part over here, that this is 25 millimeters, or the distance over there, or the length of that part over there, or the length of that part. Make sure that dimension correlates towards the question paper. So now if you're sure that this is 100% correct, then you can roll out your transparencies, and then you can make photocopies of that transparency. Now, of course, that must be 100% correct. It must be 25 millimeters, should you need to make sure. Why? Because if this is wrong, then obviously all the learners' information is also going to be wrong. So therefore, you have to make sure about that. And then this transparency will help you to a great extent to see whether or not the learner was accurate in terms of the points that you have determined. So there you can see the points over there, and it should correlate with your answer sheet. I will get to this just now. All right, so that is what I talk about transparencies. And of course, your transparencies can also go further on towards your mechanical drawing as well. It will help you and assist you a lot in doing the mechanical drawing. Of course, these areas are enlarged, so you can't use these areas. It's just for the marks. But for this area over here, for these ones, that will be 100% accurate. And of course, you will also use this part over here for your transparency in order to get your answer sheets and so. All right, so that is basically what I want to point out to you in that regard. So if we go back to if we go back to where we were just a few moments ago, those transparencies must be done very accurate, very precisely towards the scale of what the drawing is. So make sure after it went through the photocopier that it is still in the correct sequence in that size. All right, and then also a bisector, ruler, set squares, protractor, and red pen. That is part of marking, ladies and gentlemen. So you have to, by your set square, check if the lines are 30 degrees. You have to make use of your protractor in making sure that the angle at a certain point is 100% correct. All right, and then also a bisector helps a lot in terms of making sure that your distances that you're working on and the dimensions that you're working on is transferred 100% correctly in that regard. All right, so make sure about all that detail when you do the marking and when you are busy with marking. All right, ladies and gentlemen, the next I want to point out to you is, if I can quickly go up here, towards, let's say, for instance, a question like the one that we have had a few moments ago. So now we can say this learner have twisted this to an angle. We will get to the answer just now, but we have to see whether or not that distance is done correctly, and we can control it and transfer it to wherever we have to go. If this needs to go, say, for instance, towards that position over there, we can correlate and see whether those are done correctly. All right, so this with the bisector is, of course, of very good help, and it will always assist you a lot in terms of that. All right, then also the deviation, ladies and gentlemen, only 1 millimeter permissible. All right, so if it's further than 1 millimeter out, it will be totally wrong. So again, if we go to our transparencies over here, we can say, for instance, if this goes from the start position and it goes all the way up to here, you know for sure that your transparency is 100% correct, and according to the question, then you can correlate and see exactly that is 100% correct. So that distance of the learner from this point to that point correlates to towards what your dimension is. Of course, sometimes it will happen that you have to move your transparency to make sure that everything is okay and everything is fine, because the learner can place this at any distance over here. So therefore, in that case, you have to sometimes move it. And the same with windows and doors and everything that goes with that. All right, so that is 1 millimeter permissible for deviation. The correctness and accuracy is, of course, of the most important aspects that we're pointing out here. And then also, the learner must show evidence of knowledge. All right, so that is very important. Does the learner show evidence of knowledge? Does it show the knowledge? Now, I will explain that to you again with this paper where this displacement graph was drawn on an angle, and we can sort things out in terms of that when we get to this question. But yes, does the learner bring knowledge to the table? Yes or no? So if, say for instance, you do have got an exam paper, and that exam paper by say for instance is done totally wrong in terms of many of the aspects that you see over there. In other words, he did harmonic motion in terms of acceleration retardation and swap the other one around. It can also be for, say for instance, with a question paper where you can see clearly that the learner does not show much knowledge in terms of isometric drawings. In that case, it means that it often can happen that you have to ask yourself how much knowledge is coming to the table if we get to that point. All right. Then also you mark with the mistake. Again, I will indicate that to you by my option that I have with, if it gets to the CAM drawing. I will get to that answer just now. So it is, for instance, this one that you see on the screen right now. With that one, the question is, was a mistake? Was there a mistake in drawing it that way? Did the examiner say he has to start there? And did the examiner say it must be horizontal from 0 towards 360 from left to right? Or is it wrong in doing it downwards? So like this learner did just now. All right, so that is what I want to point out to you with mark with the mistake. And then also the learner should benefit of, if there's any doubt in terms of size, in terms of projecting it into a certain direction or whatever the case might be, you will give the doubt to the learner and don't take it to yourself. All right, and then also use a bisector, ruler set, squares we set. Then also, except for concessions, basically what it points out to you here, that all other drawings drawn in freehand may not be assessed. All right, paper 2, no freehand drawings, not at all. All right, the only freehand drawings that you can get is of course with curves. Now curves with your loci of a cam, that can be seen as a freehand curve. So in this case, that can be done freehand, that can be done freehand. But now if the follower is in rest, that specific area must always be drawn by means of a compass. Right, so where it rests, it's over here and over there, that must be done by a compass. In other words, your distance at all times should be exactly the same from the center up to that point over there. That distance should always be the same because of the fact that it's in rest, and that should have also been done, the rest period is over here, so that also should have been done, I don't know where this learners, I think it's over here, there we go. That rest period over there, from there to there, should also be done by means of a compass. For the rest, it can be done in freehand, and you can't discriminate with the learners that can't afford French curves and lead rulers and those type of things and so on in order to get the curves over here. What is important, it mustn't feather out, in other words, having 4 or 5 lines drawing that circle or that curve over there, and it also has to go through the exact points as it goes through and was determined by the learner itself. All right, so that is basically the freehand areas that you can get on a paper like paper 2, and then of course paper 1, it will be the hatching of the substructure. All right, exceptions of curves which cannot be drawn by a compass, like for instance in the case of perspective drawing, like in the cases of cam drawings, and also with mechanisms, that can be done by freehand. All right. All right, this one over here I want to point out to you, the benefit the learners for the correct drawn line or the feature itself. All right. To ensure consistency when marking, please make sure that the correct line is basically needs to be placed in there. Of course, paper 1 and paper 2 need skillful reading in many cases. All right, so this skillful reading and the interpretation of that is very important for learners. And that many learners have got a problem with reading. Now, ladies and gentlemen, if you take a look at this paper over here, there's a lot of reading over here. And from one paper to the next paper, these objects will not be in the same position or in the same place. All right, so if you go to paper 2, question number 4, again, this will also, that part over here can also be sometimes on the left-hand side, on the bottom or the top or whatever the case might be. And the sequence of these drawings is also not the same every time. So, but with paper 1 on house plans, most of the time, you will get that the sequence of and the placement of information will be on the same places. In 90% of the time, it will be placed on the same places. And also, if you go to the front page or the cover page or the exam paper, those scripts that's been pointed out to you at the start of any exam paper, most of them are exactly at the same spot. So yes, you can help the learners in terms of that. Right. And then also hidden detail. Remember now with this exam paper, you need to have an angle over here and you need to have an angle on that point over there. That angle is going from the bottom down towards where the circle is joined with a tangent line over there. And then of course some distance upwards, that angle comes from that point over there. So sometimes a learner should have either hidden detail or it could have been construction lines to determine the angle at this point and to determine the angle at that point itself. All right. Then the next, so if not asked hidden detail, the learner can show some hidden detail and you can't penalize him for that because that is to determine the angles on either side. Then over here they talk about cluster marking. All right. With cluster marking, ladies and gentlemen, This is normally for the points and for the marks and going through the points and all that for acceleration and retardation. Now, if you add up this 1, 2, 3, 4, 5, 6, 7, 8, 9, that gives you 4.5. So if everything is 100% correct and everything is in place according to what has done over there, you can make a cluster moderation or cluster mark and say this is 4.5 marks for this principle that has been shown here by the learner. If the learner has got everything correct. Now, of course, if there's one of those lines is wrong, so therefore you can't have 4.5 minus half and something like that. So then you have to go through the detail of marking. Over here, I want to point out, I also showed it in paper 1. This, what you see over here, is the correct answer. So the distance from that point towards that point is what it's supposed to be. You've made your transparency, and now the learner has got this point shorter towards this position. All right. It doesn't mean that the isometric drawing is wrong, because still the learners show some competency in terms of this line and that line should be parallel with each other, and this line and that line should be parallel with each other. So if it gets to that point, you give a 0 mark for that specific point. That is wrong. That is supposed to be there. I know that one is also wrong, and I know that one is also wrong, but the learner has got the ability to say that parallel line will go parallel towards that line, and this one also parallel to that line. So you can give half a mark for the rest of the drawing itself. Now, in this case over here, the learner has got this angle wrong. You can see that that distance over there is by far longer in his answer than what it's supposed to be. So again, this is the position of that line. That position is wrong. It's supposed to be there. It's supposed to stand at least at that point over there. So this is wrong. But the learner knows that and has got the ability to say, right, these lines over here, this angle is also wrong. The position of this angle is wrong. So I will see that is wrong. But he knows it should be parallel. So therefore, give him the mark for that part over there. So that is wrong, and you can still give him that mark. This one is also wrong. You can also give that one as wrong. But then, of course, this and that is correct. So therefore, you will get the marks for that. Competency, the knowledge of the subject. If a learner doesn't know that this is a flat surface and he carried on with that line further onwards, that complete line will be wrong. Not only that portion over there and correct for that one, it's the complete line. It's only 1 mark for that specific point. So therefore, the learner will lose the mark for the complete line over here. Also the opposite way, if it goes from there to there and it's flats over there, there's no lines over there, that is the mistake over there. So for that complete line, it should be wrong. That will be right. That will be right, that will be right, and that will be right in the process. All right. Once you're done with it, of course, this is the maximum marks. You can't give him 12 out of 11. You have to remember that you have to, if it's 10 marks, to divide by 2 to get the mark out of 5. So therefore, don't put the complete mark 10 there. You have to divide it still by 2 in the process. All right. So if you mark, those points must be there. If that is part of the memo, then you must show those marks over there. You can't just check it up. Now, of course, we have cluster marking. So if this, according to your transparency, correlates, so therefore this is 1, 2, 3, 4, 5, so it's 2.5. So you can write down 2.5 over here. And then, of course, your center line is correct, the center line is correct, and the size of the circle is correct. Then you can give the marks for that. So in that case, but you have to show you have been visited these spots over here. You must show that you have been visited these areas over here. All right, so if the 2 center lines and the size of the circle is correct, you can write down 1.5 over here. And if the follower is 100% correct, you can write down 2.5 over there. All right, so that is what I want to point out to you. Then you have to transfer the information, of course, to your assessment criteria. Indicated in your assessment criteria over there, wherever you go. So it's 2 and 3, and that gives you 5. So put it in 5 over there. And then, ladies and gentlemen, if you are starting or going over to number 2 for the second part, this is number 2. So what I used to do is I use my blue pen in terms of doing that. I will use a pink pen in doing that. I will use a green pen in doing that part over there, and I will use my red pen for this part over here, and my orange pen I will use for this part. So that helps me a lot. It also helps the learner to say, if that is orange, these are all the orange marks, and this is where it derives from. If that is blue, for instance, then he will also be able to make sure that this is all where it comes from. And so that is pointing out to you each of those components exactly. But then, if you do this second part of the question, write your answer in this vicinity. If you do the fourth part of the question, write your memorandum answer numbers over there in this vicinity, and of course for 5 in that vicinity over there. No marks must be deducted for line quality or neatness. Right, you have heard it correct. No marks to be deducted, sorry, for quality of neatness. All right, it's except for the fact that if there's specified for the curve quality. If the curve quality mustn't be feathered in the process, right, so it must be a smooth line going from one point to another line, then you can say neatness is okay. But if it's feathered or if it's a combination of lines, it's unacceptable. Right, should not be penalized for unnecessary without compromising validity, reliability, and fairness of the question. All right, so also, if say for instance, if a learner has got some extra parts of it, let's say for instance with the isometric drawing, for part of the isometric drawing, this wasn't asked, this part over here wasn't asked because it's a section drawing over here, but he did this. You can't penalize him for that. The learner penalized himself already in terms of the fact that he went and wasted some time on extra content, right? So extra work that he has done over there. So yeah, the long and short is basically you can't penalize him for extra areas that has been done by the learner itself. So yeah, that is what I'd like to point out to you in terms of that. All right, then also once finished with the question paper, you calculate the totals, write down at the bottom of the assessment criteria and encircle the total. So therefore, for instance, this question totaled and you encircle. Now this, of course, will need to be transferred to the cover page, which is over here. And then obviously you will do the rest of the questions. There was no attempt on this question itself. So in that case, no attempt tells you over here you're going to draw a line through, you're going to put 0 in there, and of course that will also be transferred. Make sure that your 0 is a 0 and not a 6 or a 9 or something like that. And then also no tippets allowed on any answer sheets, of course from the learner and also from the marker itself, and not leave any section of the question unmarked. Everything must be marked. So therefore there we transferred the 0. Make sure it's a nice round or oval shaped 0, and then of course you will transfer everything correctly, and then after that you will total. Now if it is divided by 2 and it's 61.5, 61.75, then in that case it will roll over to 62 in that case over there. All right, so that's where you round up for the first time, not over here and not over there. You transfer the half a marks over here, and then from there on, once you've done it up towards the total, then of course you will get that mark over there. Now if the HOD or your colleague is moderating this paper and he gets a different answer over here, he gets 31 for that one, that's your HOD, then of course that will change, and of course the total will also change. If you divide that into that, then that gives you 62.75, so he got now 63% for this exam itself. All right. Then of course capture the marks on the teacher mark sheets. From the teacher mark sheet you will go to SA SAMS and you will capture the marks on SA SAMS, and that needs to go to EMIS. Please, ladies and gentlemen, your EMIS operators or your SAMS operators at your school must capture these things in time, because at EMIS they take all the EGD marks, all the life science marks, all the science and mathematics marks, and then of course the subject advisors must analyze, and the provincial educational specialists, they need to analyze the marks. And then if there are some schools that has got no marks on EMIS, then of course it makes it very difficult to get totals and to get averages of the province or something, stuff like that. All right, so that is what I'd like to point out to you in this regard. The next I want to point out is this part over here. I will go quickly through this because this is not a content training. This is just helping the markers. It must be in third angle lithographic projection, so all of the drawings should be done in third angle in paper 2. And then of course the symbol of third angle lithographic projection should be always applied 100% correct. That is the symbol telling you this is third angle lithographic projection. So if the circle is larger, if the circle is on the right hand side, if the circle is done wrong, then that should be wrong or seen as wrong. All right. Then sectioning, if it goes to sectioning, some areas are not allowed or permitted to section. So therefore, if I go towards this position over here and I have to section this part over here, the key over there should not be sectioned in the process. All right, this is partly sectioned. For hidden detail, it shows you over there on that side, but the partly section over here has been given to you in this regard. All right, this with assembly drawings, of course, we will assemble the drawings, and the moment you go to assemble drawings, it's when there's 2 or 3 areas that are being placed together. All right, I will get to that just now. That's your section line. The hatching should be placed in there, and then besides that, hatching should be, according to SANS, the distance between hatching, the distance over there and over there should always be the same. So therefore, the hatching is type B line, and then hatching will also be equally spaced apart from each other if there's a mark coming from hatching itself. All right, that's your section line. Many learners are still struggling with that. That is with the section line on third angle geographic projection, it's a center line. With first angle, it will be a solid line. Then you will have, there we go, with first angle, you will have a darker end at the end over there, and then the arrow is a bit larger, and it's also been pointed as a darker end on this part over here. You will see in this coming exam, this is also what is part of this exam memo discussion. You have to name it. Also, again, the direction of the arrow is important because you look at it from this way, third angle, and place it over here, also important. And that is a sectional front view. So many times learners forget about the section part, the section front view, because it's sectioned over there and it's sectioned over there. So that's what you see in that regard. This is an offset sectioning, ladies and gentlemen. That is a question that was asked many times in the past. So in other words, just the portion has been sectioned out, and that is what it points out to you. Only this part over here will be sectioned, and of course where it goes angled, it should have a darker end over here. There you can see the darker ends at that part over there. This question was asked in 2019, and then they ask, what is all of these about? Name the type of sectioning produced by TT. There you go, it's offset sectioning. All right, so then this is also part of this memo discussion, where the offset sectioning, if it goes through a hollow area, in other words, there's an open area, it stays a center line. If it goes to a solid area over there, then it stays, in that regard, it stays a solid type B line. All right, so that is very important. You will see this is also part of your memo. Then the next I want to point out to you, this is the direction of hatching. So one direction, and then obviously the second will be going into opposite direction, and then the third, obviously it will be the same direction as this part over here, and then you make it a little bit closer to each other. The sectioning has been asked in previous papers where the direction was done wrongly, and it asked what is wrong with this hatching over here. Then with ribs, very important, also part of this complex assembly drawing that we have had. You will fence it off over there, but you don't do hatching over here. Now, ladies and gentlemen, if no hatching was applied at all, of course you will get a mark for no hatching. But again, the knowledge of the learner shows that he has got no clue if it gets to hatching. So in other words, there's no hatching at all. So he can't get this mark for this part not hatched because he doesn't know anything of hatching itself. All right, so only if there's hatching applied, then you apply the principle of non-hatching. All right, so that I will talk to you just now in the memo discussion. Then of course you've got a rib or a web in terms of this part over here as well. So if I section this part over here on that specific line, it means that the front part will fall away, and that tells you fence it off, no hatching applied at that area. So therefore that's a rib over there, that's a web or a rib. The answer was web or a rib. No hatching over there, so that's what was pointed out by F. If it's a solid point like this one over here, then of course that will be all hatched in the process, because that's not an enforcement web or a rib placed inside there. This is for bearings, also applicable for this question, paper 2, question 1. That is what you see in terms of that, so therefore that is the part over there. Then part sections, the learner should know what is this. The examiner is asking what is shown by this part over here. It's part section, in Afrikaans gedeeltelike snit. So in that case, it's a portion being taken out, and that's part section that you get there. All right, this is revolved sectioning or a ventral slit. That is revolved in other words. Sorry, there we go with this revolved showing the profile. It's revolved showing the profile. In that case, over here, 2017, it was asked what was shown over there. So that's revolved sectioning. This is removed section of vacant of a verwijderde snit. Remove sectioning. It means that this portion has been removed. Can you see there's no detail at the back, or there's no detail at the back over here also been drawn in, and that's why it is removed section. Also applicable for the question paper that we have to answer. All right, so there you can see no profile of the rest of the components. There are some other components, but nothing of that. It's just the profile of this area, no background information, and then that is when you get a removed section. If the profile of everything was over here, then it's a section drawing, but in this case, no background of the components over here, so that is giving you this option. All right, so too thin to hatch, so therefore it's just dark lines. This is successive sectioning op een volgende snit, one after the other one, after the other one, after the other one. So this is what you will see in successive sectioning. It's also been asked in 2018, this type of sectioning, so please make sure about that. And then also this is aligned sectioning. Many learners make the mistake by drawing an oval over here. It must first be pivoted outwards towards this position, and after this position, then you can project it back and draw it as normal, because the arrow is pointing into this direction and the arrow is pointing into that. So you align it into the same, so aligned section or stel snit, and then you take it back towards where you go. All right, for gears, this is important. For the past 4 or 5 years, they've asked gears in terms of that. So that is what you see in terms of that. And then this is equal and unequal numbers. It doesn't matter. Then over here, this is pins. You don't section this part. It's too small. Rods, you don't section. It's too small. And then, of course, this is a dowel. Also part of the question that was asked in question question number 1. More specifically, question 7 at question number 1. And then also pins. These are pins that you can see. No hatching according to that. No hatching to keys in terms of that. So therefore, no hatching at all. Bolts and nuts, ladies and gentlemen. 50% of the question paper in 2019 for the complex assembly or the assembled drawing was nuts and bolts. 50% of that, 45 to 52 marks was given for nuts and bolts and the hatching of that, and also for the information that you get on that part. So this is very important. Learners should know to edge off the nut on the ends over there. Learners should know for the left view it stays square, because that arc goes up to the top, and it means that if it goes up to the top, it means it makes this thing a rectangle over here, and that's why you get that rectangle points over there. Then of course, if I go back for one moment, if it's hollow, it's not very often that you will get a nut to be drawn solely alone, but yes, then the broken circle will be on the outside, the solid circle inside, and the broken circle will be on the material side of this part over here. All right, so then if it goes to bolts, pretty much the same. You can see the edging over here on the bottom over here, and also the edging on that point over there. This is very important to get to the 45, so I'll get to that now. Can you see now the circle has been basically solid, and then the material side is broken in that regard to tell that there's thread that goes into the inside over there. All right, so again, make sure about that information. Also for the left view, it's going to be square, and with stats, exactly the same. You can also see material side has been broken circle over here. Also applicable for the memo discussion for now. Diameter, learners should know what the size of it is. Then diameter comes from the nut and the bolt itself, and it's applicable to everything. The cross flat, question that was asked in this question paper, the cross flat tells you it's from top to bottom. All right, it points out to you from top to bottom where you go for that position. All right, and then also 1.5 of diameter. That is the formula that you will use for that. This question over here also was asked in this question paper. 0.8 of diameter, forget the height of a nut itself. For the bolt, if you go to the bolt, this gives you 0.7 of diameter. And then for the thread itself over there, it gives you 0.1 of diameter. All right, so that is what you see, what you can see in terms of the diameter and also with the threaded parts over here. This is what I want, what I pointed out to you. Material side will be broken. This over here, material side on the inside will be broken. This is also applicable for this memo discussion for question 4. And then, of course, with the stud, you will also get the material side being broken. Washers, you don't hatch, you keep it clear. This comes from the drill that's been sharpened at 30 degrees over there and 30 degrees over there. Then, of course, this is been tapered at 60 degrees, and that's why your thread should be 60 degrees over there. And then, of course, this is 45 degrees, so therefore, for the bolt, that should be 45 degrees over there. All right, so that is 60 degrees, also 60 degrees over there that you will see. Now, this is coming from 2019. This is the question paper I've pointed out to you. Can you see how many marks of this, of what I've explained to you just now? The 45 degrees, the 60 degrees over there, the solid line, line type over there, line type on that side over there, and then, of course, the rest of the head of the screw itself. That is 45 degrees edged off, we said just now. And then from there on, that is 60 degrees for studs or for bolts, it doesn't matter. Then if I drill a hole through this and section this part in half, that is where the hatching will go up to. Now, if I put the thread inside there and on that side, that is basically pointing out to you that the hatching will go all the way to the side of the material, up to where it goes. All right, now you should also know that bolts don't need to be hatched, so therefore that will be cleared up this area over here, but the hatching will still carry on onto this part over here, so therefore it swap around. Can you also see the type B line over here, type A line, and it goes back to the center of the hole, and then this will be causing then, of course, a type B line that you will see in this area at that point and at this point over here. All right, so there we go with that part. And then also, whether if it's a stud, if the stud stands out, that should be 45 degrees, that should be 45 degrees, open clear areas, and then, of course, the thread on that side. All right, so ladies and gentlemen, that we showed you just now, that's where the thread comes in, and then if you take the bolt, you put the bolt inside there, stud, doesn't matter. And this is also applicable for what we have done on this mechanical question. So again, 2019, this is another option of where you get the screws and stuff over there. Interrupted view, this part over here, it was asked in earlier exam papers by DBE itself, so therefore interrupted view, still the dimension is from side to side, the true dimension that you will get. All right, this is a tapered shaft that you see over here, square on the shaft, also applicable for this question paper, that is shown by the square of the shaft. And ladies and gentlemen, if you have to do dimensions on a square, on that square of shaft over there, it should be a square 20 by 20 wherever it goes. And of course, the real dimension will be placed in that part over there. Then this part over here, it points out to you the angle. So therefore, that mark that you get over there, the mark that you get over there is because of the angle. Now, these is not necessarily, could have been hidden detail line. It could also be, let's say, for instance, construction lines in order to get the angle of what you get there and the angle. So therefore, it's the position that counts, and it's not the length of the line itself. All right. Then square. There we go with a square on the shaft itself. That has also been asked in 2019. Knurling. This is also part of this question paper. What's the purpose of knurling? It's to prevent slip on the surface itself. And this is diamond knurling. This is your answer that you will get over here. It's called diamond knurling. We will get to that just now. 2019, 2018, it has been asked. All right, this is a circular, bottom been sectioned over here, the top not sectioned because of the gap that you see over there. Then if we go to springs, sorry, I just want to go back one. There we go. This is the spring itself, flat on the bottom, flat on the top, and at more or less 15 degrees, it goes further downwards for a spring. For a bearing inside a shaft, it will look like that. And of course, if the shaft is not there, this is also applicable for this question paper. This is a bush for drawing the bush itself. All right, so that is what you see in terms of the bush. If you should section the bush, it will show the profile like this one over here that you can see. All right, there's the profile being shown to you over there. All right, then, ladies and gentlemen, this is a question for, I think it was 2018. spot face. If it's less than 4 millimeters deep, less than 4 millimeters deep, it's called a spot face. It will also be called S face, spot face in other words. Spot face does not necessarily go downwards, it can also go upwards, like this one over here. It's also called a spot face. All right, so that is what you have to understand in that regard. All right, so there we go with this part. Then if you go to this part, if it is larger, deeper than 4 millimeters, if it goes deeper than 4 millimeters, then that's what we'll call a counter bore. All right, so that's C-bore or counter bore. All right, and that was asked in 2019. Over here, what you see over here is the gears itself, the representation of a gear over there, and also the representation of a gear if it's sections on equal and unequal numbers of teeth. If it doesn't say anything, you can basically go for this representation where it's clear and clear, or maybe hatch to the end. That's all going to be correct. Okay. 2018, 2019, I think we can go back to 2017, and we can also include the May, June exams in terms of that. All right, basic welding symbols. I'm not going to stand too long still on this part over here, but make sure that the learners understand the information, what goes where and where is it applicable for each of those areas that you can get when the learner needs to answer this. These are symbols that will be drawn onto those areas, and the shark fins and weld all around and do it on site and mark on the other side of the arrow itself. This is the type of question that you can get. Now in this question paper it wasn't asked for welding symbols, but this comes from an exam paper of 2019. It's content knowledge, in other words, that you have to bring to the table. Surface treatments, this question was asked in this question paper. So therefore you have to know what goes where and which one exactly is indicating to you the type of finishing, the type of treatment that you will get: parallel, circular, closed, radial, and so it carries on. All right, so that is basically what it points out to you in terms of this detail over here. All right, then this question 2019, it was also asked, so therefore there was a lot of questions coming from 2019. Then over here, the surface treatment must be applied by surface. It's machined, and then also it must be 90 degrees. And then also tolerances. If you go to tolerances, it means that the upper and lower tolerance. You will see over here it points out to you an upper tolerance and a lower tolerance that also needs to explain to the learners in that regard. All right, so if it only asks for the lower, you only do the lower. If it asks for the upper and lower, then you do that. That's basically the simple calculation that you will get to the answer, and you can do a simple calculation like that. So of course, if the learner doesn't have his calculator with him, it's going to waste a lot of time in the process. All right, in reference to tolerance, what determine the minimum height? All right, so there's a tolerance, there's a positive and there's a negative. They're asking for the minimum height over here. So if you go to the minimum height, you will subtract the two, this one with that one, and to get to the answer itself. All right, so there we go again. Tolerance determine the minimum dimension. That is minimum. It's only applicable to the bottom. It's not applicable to this upper part over here. It's only applicable to the bottom part that you have to have. Ladies and gentlemen, that brings me up to the end of the session over here. Now I'm going to do the memo discussion. So this is the question paper. It points out to you September 2021, paper number 2. So there we go with that portion over there. All right, so that is a 3-hour paper, and that was a total of 100 marks. This portion over here, and this is what I'm saying to you, that learners can save a lot of time if they know the information that has been given to this portion over here. All right, so if the learner knows this information, then he will waste no time in terms of that. What is very important is, of course, it is third angle orthographic projection for paper 2. So that is important that you have to know. All right, so if we go to the first question over here, if I can quickly go to the answers, what scale was used towards this drawing itself, you will see the scale over here is, okay, let me just quickly sort this out. The scale that it points out over here is a scale of 1 to 5, in other words. So that's the scale we're talking about. So the first answer on your memo discussion will be then, of course, a scale of 1 to 5, if you go to this part over here, 1 to 5. Next question is in what town it's derived from, or is the engineering company. This is Randfontein, in other words, over there. It points out to you Randfontein. All right, so although the owner stays somewhere else, although the engineer can be from another town, the engineering works comes from Randfontein in the process. All right, so next question, what they ask over here. Surface finishing must be applied at surface A. Now we have done this. This is diamond knurling at A itself. So there you can see the diamond knurling. So your answer, your correct answer should be diamond knurling in that regards. All right. Next question was the file name of the drawing. What is the file name of the drawing itself? All right. So if we go towards the file name, if I'm not mistaken, it was somewhere over here. I can just maybe quickly have a look over here, and I think it's a bit more to the left. File name, there we go with the file name. It's June 2021. All right, so that's the file name of what you can get over there. And then also the next question is the unspecified radius. So there's the unspecified radius that you can get there. It's basically sorry, I just want to get control over here. It is unspecified radius. It points out to you 5 millimeters. Which views of the pulley system are being shown? All right, so now this is the pulley system. These are the views that they're pointing out to you, ladies and gentlemen. Now, if you see the two views next to each other, in that case, it means that this can be the front view and this can be the left view. It also tells you that this can be the front view and this can be the right view. All right, but if you go to the question, if the question points out a sectional front view, it says there, sectional front view and a right view is shown by this view over here. Now, of course, sectional front view should be here and the right view should be third angle placed on the right hand side. So view 1 should be then, in that case, a sectional front view, and it's important to put in sectional over there. If it's not there, it's not only a front view, it's a sectional front view. The learner loses the complete mark simply because of the fact that it's been given to the learners over here. It says there clearly it is a sectional front view. So the word sectional must be forming part of this. And then, of course, view 2 over here is the right view that you see in that regard. All right. Next question. What is pointed out by arrow D? And the English was E. So I've sent it on the WhatsApp group. Changed the E to D, so that was one of the mistakes on the exam paper. So that is a pin. It's not tapered. You can see the dimension on the top and the dimension to the bottom is exactly the same. It doesn't go smaller to the bottom or something like that. So that's not a tapered pin. It's just a pin. So your answer was supposed to be a pin, a dowel or a pin itself. All right. Then the next question, what is pointed out by B? There we go with that part. That is the rib. We have done that just now. So therefore that is the web or a rib. Both answers could be seen as correct. All right. And then the question over here. Formula used to determine the height of a nut. All right. So the height of the nut is simply 0.8 of diameter. We have done that just now. So therefore that is diameter multiply by 0.8. Then also another question that was asked in May 2021. That question paper. What does AF stand for? Of O P, dink ek is die Afrikaanse deel daarvan. Across flat. That is for the across flat. In other words, from the one flat side of the nut to the other flat side of the nut itself. All right. Next question. How many pulleys need to be manufactured? All right. So go back towards your question. It points out to you number of pulleys over here. They required 40, so the answer should be 40 in that regard. All right. Then the next question over here is the projection symbol system that has been used. What system has been used over here? Now that is question paper number 2. This is third angle geographic projection, and the learner could get the answer from this part over here and the fact that it's been given to him a front view and a right view. So those two are basically coming from third angle geographic projection. So your correct answer on this was be third angle geographic projection. All right, then it's asking you the questions on this symbol that you see over here. What is 1? What is 2? The type of machining? What is the sample length? What is the surface treatment that you can, the allowance that you can get? Are you allowed to use machines or multiple directions or whatever the case might be? Are you allowed to use a machine in this case? Yes, that's basically coming from this question over here. The roughness value, sorry, the direction of finishing is 4. This is direction of finishing. This is multiple direction. All right, so that's basically where 4 comes from. The roughness value that you will get, the roughness value is, if I'm not mistaken, it is number 5, and then which is this one over here, the roughness value. You can't go deeper than this. Then you're going to take off the paint, and you're going to take off the surface or whatever the case might be. Then the next question of this one was the sample length. For how long can you carry on with that part? That is at number 3. That is the sample length pointed out to you in that case. We have done all of this just now, and you can just check it up with this PowerPoint slide that we have done just now. All right, then the method of treatment and then also machining required, that's number 6. So the method is turning, and number 6 pointing out you are allowed to use machines in answer this question. All right, ladies and gentlemen, then the next question is name the type of sectioning at the section view C. All right, so now I've made this all the same in order to help you to get this direction at C is what is derived from that. Now it doesn't show detail. It doesn't show detail, so that's not a sort of left view of this part. It's only the profile that has been cut over here. So in that case, it is a removed sectioning of what you can get in that regard. So that's the answer of removed sectioning. Sorry, that's the answer of removed sectioning. Okay, next question. After this question was, it points out to you on the drawing, measure and supply the sectioned view C of a dimension. So you have to supply the area at C with a dimension. Now, there's already controversy going on in this regard, ladies and gentlemen, because in fact, a scale of 1 to 5 was used. So therefore, the scale of 1 to 5 was used in that case. So if a learner, say for instance, I'm using this part over here, and I just want to point out to you on this section of this drawing. This learner has got this dimension measured at 15, but he wrote 75. All right, now in fact, if that's 75, the answer is 100% correct, because you have used the scale of 1 to 5 in order to get the 15 millimeters and multiply that with the scale that gives him 75. Right, but now the learner forgot to put the square in, because the correct answer on this part over here would be square 75. All right, so over here I've got 15 millimeters because the wording wasn't 100% correct. So therefore now it's whether we have to give the benefit of the doubt to the learner itself. So therefore, if we go to this part over here, the benefit will be, because of the wording of the examiner wasn't 100% correct, you can say if that distance is 15 millimeters, you put a square for this round. Right, so half a mark for the square, half a mark for 15. But if the learner wrote 75, he forget about the square that is in there, so therefore no square was shown. So he will lose a half a mark for the square, but he will get the mark for 75. So 15 or 75 can be seen as correct in that case. So it can be 15 or 75 as seen as the correct answer over here. So this will be changing to 15, or it can change to 75 for half a mark, and then of course this part over here. And that's where I say that causes because of the benefit of the doubt to the learner itself. All right, the next question, it points out on the drawing, measure and supply that we have done just now, insert the cutting plane on the drawing itself. All right, so now we have to go to this part over here. The cutting plane can only be placed in this area over here. It can only be placed over there. It points out to you a sectional front view, so the direction of view will be from left to right. So if I go to my answer in this regard, I will go to this as part of the answer. You can see it's called notated A, so therefore the learner get a half a mark for that. The learner will get the half a mark for the direction left to right. All right, so there we go with the direction. And of course, this part must be drawn in a darker option or grade that you will see over here, and that brings you the darker end. So that's 1, 2, 3, and of course on the top it also got 1, 2, 3, and that gives you a total of 6 marks for this answer over here. So over here, coming back towards this part over here, it gives you 6 half a marks, and if you divide that, it gives you 3 marks for that part. Right. In the given space, indicate by answer 17, draw freehand the conventional representation of a bearing. Right. Now, ladies and gentlemen, there's the answer. It's supposed to stand over here. Right. Going to the answer, it is pointed out to you by this point over here. That is the bearing. Right. There's no shaft in there. It's just asked for the bearing. All right. So again, we will have the symmetry principle being applied over here. Maybe I can just move this a bit up towards that point. All right, so symmetry, then freehand, it must be freehand because they asked for a freehand. So half a mark for freehand, so half a mark for this little square which is on this side, and then the solid line over there, and then of course half a mark for the line going onwards and going. If you put a shaft in here, nowhere a shaft was part of the equation, then he's going to lose the mark for that part, and he's going to lose the mark for that line over there, unless the shaft has been having a shoulder on that side of itself. All right, and then the symmetry part, which is basically pointed out to you over there. Okay, so that brings us to this question over here. If you total everything up, it will go up to 27 marks, and from the 27 marks, it is the final mark for the examiner itself. If there are any discrepancies according to this, then please contact me, and I will spread the information on the group itself. But yes, that is basically pointed out to you very clearly. Next question. This is the cam. It is pointing out to you on the cam a wedge-shaped follower being given start position S at 0 degrees. Right, start position S. There we go. S at 0 degrees. And there we go with this bottom part over here where this information was given to you. All right, now given will be, did he measure 80 millimeters downwards? Why 80? Because it still has got a 20 millimeter clearance over here. All right. Besides that, is it 13 millimeters from there to there? Is it 60 millimeters from 60 degrees from there to there? Is it 35 millimeters going from top to bottom? And does it show a diameter of 28? That is given. That is the given part over here. So that you have to make sure of. All right. Then the question is, specifications. It points out to you, the follower reciprocates on the vertical center line. Vertical, up and down, in other words, from top to bottom, center line of the camshaft. The minimum distance from the lowest position of the follower to the center of the camshaft is 20 millimeters. Many teachers said, but now, if it goes down with 60 millimeters, why do I go for 80 millimeters over here? All right, why is it 80 millimeters over here? Simply because of the fact that that position is from that point 60 downwards for the maximum, and then a clearance of 20 millimeters that is pointed out to you over here. So that's the clearance that's pointed out in that case. The direction is anti-clockwise, so you're going to number in a clockwise direction. Cam. The cam imparts the following motion. The follower falls. Now that word falls tells you you have to go from that point, the starting position, downwards. 10 millimeters for 30 degrees over there. Then the next portion is the follower falls for another 10 millimeters over the next 45 degrees. All right, so then that goes for another 45 degrees. Follower dwells for 45 degrees, and then the follower falls for 40 millimeters by acceleration and retardation. That is the point, the position that you see in that regard. And then the follower dwells for another 45, so it stays in position for 45. The follower rises for 10 millimeters over 15 degrees, and then the follower rises for 50 millimeters by means of simple harmonic motion, and then over the next 90 degrees it goes to maximum position. Right, so we've got a harmonic motion, we do have got acceleration and retardation, and the instructions is draw to scale 1 to 1, 30 degrees equals to 8 millimeters, right? And then also complete the displacement graph, and then label the displacement graph. That's very important. The labeling should be part of this part over here. and then also project and draw the cam profile from the displacement graph, show the direction and rotation on the cam profile by inserting degrees. No arrow is asked, so it's no question, no marks for arrows, it's just the degrees for the direction. All right, and then also show construction lines and projection lines, and then show all center lines of what you have to draw. Okay, ladies and gentlemen, back from this part over here, let's go to the answer of this part over here. All right, first of all, given. What is given? That is basically the following red points that you see over here. The center line is part of given. The center line is part of given. This must be a diameter of 28 millimeters. That can only get the mark if that is correct there. What is also given? If I go to the top, this was also given to me. So it's 1, 2, 3, 4, 5, 6, 7, 8 marks. And then over here, if the clearance distance is 20 millimeters, if it's 19 or 21 millimeters, you can give a full mark for that part. Right, so that is a full mark. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 for the line there on the bottom. All right, so that gives you, divide by 2, gives you 5 marks over there. Then the graph construction, that's the second part. That is blue, in other words. Graph construction, the baseline length is 96. Now, how do I get to 96 millimeters? Remember, the graph tells you 8 millimeters represent 30 degrees. So in other words, that's going to be 8 times 12, and that gives me 96. So that's the first mark that you will get for that part. The second part, did the learner divide it into 12 equal parts? That's your second mark that you will get there, 12 equal parts. All right, the height of acceleration and retardation. Now remember, he went down, and he went down again, and he rested, and now that remaining part over here is 40 millimeters. So if that is 40 millimeters, sorry, this is messing up now. All right, if that is 40 millimeters, you can get a half a mark for that. Okay, sorry, I missed out this one. Subdivision of 15 degrees. That is these smaller increments that you see over there, and that are those smaller increments that you see in that case. That's the subdivision of a half a mark over there. All right, so then the height of this part is this 40 millimeters we set, and then also line divided into 6 parts. In other words, this line should be divided into 6 parts. All right, if the line is equal 6 parts, in that case, you can get the half a mark for this divisioning of the line itself. All right, so line division in 6 parts. First half construction, remember, with acceleration, retardation, go to the side, back to the original. Go to the center, sorry, and then back to the original. Third one goes to the center. The fourth one, second half, division of line, second half, go to the center and then back to the end point. Go to the center and then back to the end point, and then the last one goes straight there. So this is for this divisioning. Is that done correct? That's the first divisioning, and this is the second divisioning of this part over here that you see in that regard. All right, then first half construction, second half construction. Semicircle. If you take a look at the harmonic motion, the semicircle, did the learner draw a semicircle? If the circle is divided into 6 equal parts, that's the semicircle. The radius, of course, ladies and gentlemen, must be 25. It must show radius of 25 or diameter of 50, because it goes for 60, goes 10 upwards, and then from there on it goes 50 millimeters that you see over there. All right, then the circle divided, that is this portion over here, circle divided into 6 equal parts that you see over there, and then also the projection. Did the learner project? These are the projection lines. There you can see. Did the learner project the lines from there onwards to this part, and then from there further onwards for later reference that I will give you just now. All right, then the displacement graph, this part over here, that's for the displacement graph, it points out to you this portion that has been drawn in over here, the green part. Now, ladies and gentlemen, this is the coordinates of 30 degrees and 10 downwards. If that coordinate is 100% correct, 30 degrees, 8 millimeters in other words, and 10 millimeters downwards. Now remember, if the learner went for 10 millimeters, and it says clearly 8 millimeters, you will subtract once the mark for equal parts of 8 millimeters. Now he has done the mistake, he has been penalized for the mistake, so now if the learner goes for that 10 millimeters, of which he has already been penalized for, and 10 downwards, you still give him the marks for this one. Of course, then in that case, it's not applicable to use the transparency anymore. So then you can't use the transparency, then you have to measure. All right, but now if you go for that 8 millimeters and 10 downwards coordinates, if you go for another 10 downwards and 45 degrees, 30 plus 15, 45 degrees, that coordinate will be correct. If it's done 10 millimeters apart, already penalized, mark with the mistake. So 10 millimeters with the mistake, in other words, 10 downwards, 15 degrees, that is the new coordinate, mark with the mistake, give him the mistake in terms of that. Then it rests, just a straight line, coordinate of that part over there. For 45 degrees it rests to 120. Then from there on it goes downwards, drops downwards, acceleration, retardation. You have already done the division and division, that is already been done in blue. Now you have to say, does it go through? Yes. Does it go through? Yes. Does it go through the intersection point? Intersection point, yes, it goes through. So therefore you give him the marks for that. Again, place your transparency on top of this part. I can maybe just quickly take out a drawing over here. Take your transparency. I just want to get the correct transparency. This one over here. And in this case, let me just quickly get upside down and everything correct here now. So there we go with the start position. Now that curve that the learner has done over here correlates with my transparency over there. So that works out perfectly, and so we can say this is 100% done correctly. So yes, we can give him the marks in terms of that part over there. All right, now it rests again. All right, so again you have to have your 45 degrees and you have to find the coordinates of that point. If I'm not mistaken, the question was pointed out to you over here, to the learners. Yes, over here. This part of the question I put in this way to indicate that 40 millimeters falls for acceleration retardation to 120. Now at least all the learners are supposed to be by the 210 degree position. Sorry, 210 degree position. So if the learner falls apart over here and it doesn't have anything over here, at least you can give him the mark for that part over there, because he started at that specific point now again at 210 degrees. So that is the line that we're talking about. If you go down with the line, it points out to you starting there. So whatever is wrong up to so far, if he starts at that point, you give him the mark for that part. Then it rests, give him the mark for the coordinates of that part over there. It rises for 10 millimeters for 5 degrees, seems to be. Yes, 15 degrees, sorry, 15 degrees up to that point. And now, if we have to go to this portion over here, again, I need the coordinates of that point over there. So if the learner has got a 45 degree line over here, you can only give him the one coordinate, but now where is that coordinate? Has he got it right in terms of 1, 2, 3, 4, 5 marks, or 1, 2, 3, 4 marks? Did he divide this area then in 4 marks? All those type of things. So the coordinates with 4 marks, in this case 6 to 6 over here, the 6 equal parts that has been divided in here. So that is basically what it points out to you there. These lines must be there, it must show those lines. All right, so therefore you go to that part. If the learner messed up everything and he got that 0 point and he has got the 210 start position and he has got that point on the right position, then you give him the marks for 1, 2, and 3 marks over there. All right, coming back to this learner over here. The examiner pointed out and asked that you have to start at that position with 0. The learner did that. He went downwards for 8 millimeters, which is 100% correct. So in other words, for the projection, he determined these points over here and he projected the points over here. So this could also be 100% correct if you mark this part, because nowhere the examiner pointed out that he has to be drawing the displacement graph in a horizontal position. It can be drawn in a vertical position as long as the learners start there at that point over there. All right, so in that case, I will take my transparency and I will just turn it from there on. I will turn it into this position over here. So S is supposed to be there. It's supposed to be 0. It's supposed to go out to that point. He did S on that point going out there, but he has got everything 100% correct. In terms of the positioning, he has got the projection lines correct, and then therefore this answer should also work out perfectly. If you go to this point over here, you will see that his answer is 100% correct, going through those points at each point. Now, there's a mistake over there. He never did the bisecting of the 345 over there, so he has got that point wrong, but that is correct, that is correct. That is not correct because of that bisecting of the angle over there. That is correct, that is correct, that is correct, that is correct, this one is correct, and that one is also correct. So the learner can get full marks except for that point over there, that point over there, and for that point over there, for subdividing the angles into smaller portions itself. All right, so now if you go for this part of question, everything seems to be fine. Everything seems to be 100% correct accordingly. So yes, we can give the marks to the learner and don't need to penalize him. That was number 3. For number 4, the cam construction itself. So that's number 4, which you see over there. All right, now that is for the circle division. In other words, that's the learner, there's the circle divided into, and in other words, your 30, 60 degrees and so further onwards. So that's the first portion. And then also counterclockwise, the numbering, the direction, in other words, this is the direction. Does the learner go counterclockwise in terms of that? So it goes 30 degrees, 60 degrees, 90 degrees into this direction. And then the fourth, the arc projections. Now, this is the arc projections. In other words, once the learner have got it onto the vertical line, these are the arcs being drawn to find that point. These are the arcs to be drawn to find all these points over here. So that's the arc projection that you can get. So if there's no arcs, if the learner just plot it there, plot it there, plot it there, no arcs being drawn, he will obviously lose that mark over there. That's a full mark over there, so therefore he's going to lose 1 mark if he doesn't show any arcs over here. All right, so that's what you see in that regard. By number 5, the curve quality. Of course, it has to go through the points. Now, this is where that previous learner will lose the marks because he hasn't got those points in there, but at least he has got those points at the correct 30, 60 degrees. So therefore, you'll get the marks for that. And the curve quality, ladies and gentlemen, for the curve quality, if rest period is drawn with a compass, you give him this mark and that mark. And then, of course, if the rest period is drawn by means of a compass, then you give him that mark and that mark. If it's freehand, don't give him the marks over there. And if it's freehand, you don't give him the marks over there as well. All right, so that's what it points out to you there. And then the curve quality, of course, will be a smooth line running from top to bottom, going up all the way, that you can subtract 1 mark. So penalizing, no penalizing in this case. But yes, you can. If, say, for instance, if this was drawn downwards towards this position, but still the distances has been transferred 100% correct towards this vertical line, then you can give him, you can -1 for the position at the wrong place, and then you can carry on. So yes, that is what I would like to point out to you there. I hope this clears up this portion of the question. So that is what you have to do in this case. Over here, we have got the isometric drawing. It's showing to you all different types of dimensions towards the isometric drawing. I just want to point out to you that this line over here, in fact, is the upper part of the hexagon. There's the hexagon, the bottom and the top. It's in line, so it's not necessarily that I should have give you the dimension over there, but it is in line. Yes, that is 11 millimeters. So the learner could have started from the top and then draw the hexagon downwards. So therefore, we could start there at the top and draw the hexagon downwards to find this distance over here, whatever stays over at the end over here. All right, so this is basically the top view. This is the information. So there's degrees and a distance of 15 millimeters, but no distance of what the length of that line is. There's no distance from the hidden detail line to the hidden detail line. So therefore, in that case, this need an auxiliary view for that part. There's a hexagon, and for the hexagon, they need an auxiliary view in that regard. All right, so it is given to you start position Q, which is that part. Start position Q will be chopped off because of the section line. You will see over here there's a section line going there. So with that section line, Q and this portion of the content will fall away, or the object will fall away in the process. All right, so if we go towards this answer over here, placing of the auxiliary views, that's the placing. That's the biggest possible block for the circle, biggest possible block. So he started at the right position. That is the auxiliary view, and that's another auxiliary view. 1 mark, 1 mark, and 1 marks. That gives you 3 full marks, no half marks, it's full marks. For the base itself, this is the base, it's number 2. So take out your blue pen, it's much easier to mark it in terms of that. So that's going to be 1, 2, 3, it's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15, and then over here, the center lines is for 0 center lines, obviously it will get no marks over there. All right. So, and then for that part over there, it is 1 to 2 center lines, so maybe just the top, it will give a half a mark, and for 1, 2, 3, 4, and 5 center lines, you will get 1 full mark for that part over there. All right, so that's the base. The base is 9.5, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, there's something that bothers me for a moment. Okay, so the base is 9.5. Maybe I've got the numbering not correct here. I will come back with this part over here for you guys. Okay, but yes, that is the blue part that you see over there. All right, for the next part, that's the back support, which is this green lines over here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Divide by 2 gives you 7.5. Right, so there we go with 7.5 in that area over there. Next up will be the hexagon. All right, so for the hexagon, which is this part over here, that is sort of a hexagon, 30 degrees, and there was a review of that part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17, and if you divide 17 by 2, it gives you 8.5 in that case. And then if you go to the last portion, the section part over here, this is now for 1, 2, 3, 4, 5, 6, hatching 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, gives you 10.5 in that regard. All right, so that gives you 10.5. Okay, so that gives you 10.5. I will come back with the base part over here, of which I'm a bit uncertain now. I don't want to waste time on this portion of the content now. All right, so that is what you see in terms of the base. Okay, so that is the isometric drawing, ladies and gentlemen. This is what you have to have in terms of this. We've got 20 minutes time left over. I will quickly do the last portion of this, which is this question over here. So if we go towards this part over here, it points out to you clearly in this portion, exploded view as well as the orthographic views in position with each other, the orthographic views of each other of the cable feeder, and then also position A on diagram sheet 5, page 6. All right, so that is on this position, that is A. All right, so that was also one of the mistakes that I've seen on the question paper, where it points out to you on the bottom of the base plate. I also rectified that during the course of the exam. A is at the center point at that position over there. All right, so that is the center point where you have to start. Okay, so the question is, answer the question on page 6. Draw to a scale of 1 to 1. Third angle geographic projection, the assembled parts of half section front view. The direction of the half section front view is indicated by means of the arrow. The exploded isometric drawing, draw the right hand side section. So you have to draw the of the section area, you have to draw the right hand side in section, show the apart section area of the shaft to indicate the position of the Woodruff key, and then an Allen key grip screw. must be turned completely to the base plate, down to the base plate. All right, the M15 should show 3 sides of the front view, the nut itself, and then the right view that needs to be drawn. Okay, so there we go with the grip screw. There you can see the Allen key grip screw that we have over there. Besides that, this will be sectioned in this half part over here. So there we can see the section part over here. This part over here will be in section. So therefore, of course, it carries onto the wheel. It carries onto everything that implies the shaft, the axis, everything that goes with that. And then also, this is your shaft. Point A has been given to you. So if you work on that center line, you will get the alignment of the shaft in that regard itself. All right, so there we go with that. Planning is essential. Drawing must comply with SANS. And then no hidden details asked. No hidden detail. And then the following must be added to the drawing, the projection system symbol, and then also the title on the panel, and this is the title of the panel. All right, so that is the question paper. This is the answer sheet, and the memorandum is on this part over here. All right, so now again, ladies and gentlemen, if we go to our transparencies, if we say, for instance, we have to check this view over here. Sorry, I just want to go down towards my transparency. There we go with this part. I've got 2 transparencies. The first transparency is pointed out to me in this area over here. All right, so I can maybe zoom in a little bit. No, it doesn't want to zoom in. It doesn't want to zoom out. So I don't know what's the purpose of this part over here. Okay, but anyway, so there we go with this portion over here. So maybe if we take a look at that, dimensioning is 100% correct. The learner has got 100% correct in terms of the paper. Now, there's a mistake over here. All right, so he has got a distance over here. So the position of that line, of what the learner did, the position of that line is wrong. So he will lose this mark over here, but then you can move your transparency and you can mark with the mistake further onwards. Now, again, the dimensioning is wrong, so therefore, you can move the dimension, your transparency, and work it on, and then some of those will be wrong. All right, so there we go with that part over there. Okay, so this is what we have over here. Then this part over here has been given to you in that regard, so therefore the learner did that 100% perfectly correct in that regard. Forget about the hatching. We will talk to you about that just now. Okay, so if we go back to the memo, first option on my assessment criteria that I have got over here is, of course, number 1 must be the base, and that is counting 19 marks. For the base, 1 hatching, 2, 3 for the arc, 4 for the solid line, 5 for the arc, 6 for the solid line, 7, 8, 9, 10 for the solid line, 11, 12, 13, hatching 14. Hatching is all the way down there towards that position. All right, so it's 14, 15, it's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and then of course this portion has been enlarged for 5 marks that you will see on that part, and that is also enlarged over here. Now, ladies and gentlemen, I want to point out to you this portion over here. It's very important to see that the learner has got a solid line over there, dark, point type A line. He has got a type B line on that part over there, for the hatching goes right through. So if the hatching goes inside there, he will get the mark for that part. Besides the hatching over here and besides the hatching over there, he will also get the hatching for that inner part and the inner part that is pointed out to you over here and over there. All right, that must be type A line, that must be type B line. If it's not, if it's not type B lines, of course, he will lose the mark there and he will lose the mark for that part. Unfortunately, that's the way the examiner is marking it. So therefore, we have to stick to that. And that gives you the total for the base point over here of 19. That was 38 marks being divided. All right, for the axis, 8.5, that gives you 17 marks. All right, so over here, the axis starts over here. I will see a portion of the axis over there. Axis over there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If that line is 45, 12. If that line is a type B, 13. the portion was asked to be in detail 14, 15, 16, 17, if I'm not mistaken. All right, so that gives you 17, gives you 8.5 marks in that area. All right, the base plate is the next portion I have to do. The base plate is here on the bottom. Sorry, that's not so far. That is 1, 2, 3, hatching over here, the solid line, the solid line. Remember, ladies and gentlemen, this part of the line is already been given to you at that point, so you can't give him a mark for this part over here. It's one line. It's not underbroken or broken up into a smaller pieces. All right, so that's 3 marks, and that gives you onto this part 1.5 mark of that part. The wheel itself, that is 10 marks. So if I go to wheel, this is the wheel over here. It's 1, 2, 3, 4, 5, 6, 7. Hatching is 8, 9 for the upper line, 10 for this line. Can you see it's in a different position than the bottom on the over here? 11, 12 for the line top to bottom, line top to bottom. 13, 14, 15, 16, 17, 18, 19, 20. That gives you 10 marks in total for the wheel itself. For the handle, 7 marks, so it's 14 half marks. This is the handle. It is 1, 2, hatching 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That gives you 7 marks in that case over there. Then for the bush is 5.5 marks. So ladies and gentlemen, this is the portion of the bush. I will see the bush standing out on the outer parts. That's the bush over there. 1, hatching 2, 3 for the solid line, 4 for the end solid line, 5 for the hatching, 6 and 7 if that area is not hatched. If nothing is hatched, you can't give the marks over there. It must be not hatched if hatching is applied. Alright, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That gives you 11 marks. It gives you 5.5 marks. And that is 5.5 over there. For the washer, if you go to the washer, 1.5. So let's quickly go to the washer over here. That is the washer. It's been enlarged at this portion over here. So there we go. This is 1, 2, 3. Remember this line over here that you see going down there has already been applied for the wheel itself. So therefore there's no line for the washer on the bottom over there, but it's only for the top and the top at the bottom, and then this part over here. So that's the washer, so it's 1.5, which is 1.5 over there. For the collar, it's 1.5. If I go to collar over here, remember this is the collar. This is 1, 2, and 3 for the collar itself. So it's 1.5 marks that I will see over there. So if I go to 1.5, it will be that line over there. Then for the Gr12 key, that is basically the full mark over there. So there we go with the Gr12 key is this part over here. So it's a full mark. So it's half a mark for no hatching. If hatching is applied, in other words, if there's hatching and there's hatching, no hatching over there, you give him the mark over there. And then this is for the arc itself. So that gives you a full mark. In other words, 2 half marks for the Gr12 key. All right. Then also for the tapered pin that you see over here, that gives you 6 half marks. The tapered pin is this one over here. Of course, the upper part should be larger than the smaller parts. End it off, end it off. Then you get 1, 2, 3, 4, 5, 6 divided by 2 gives you 3 marks in that. Then the grip screw. Now look how much the grip screw is counting. Again, nuts and bolts and grip screws is counting a lot of marks in terms of that. All right, so there's the grip screw on the bottom over here. But then it's been enlarged in this area over here. All right, so now all that I've explained to you earlier, 45 degrees, 45. If that's 60 degrees, you don't get a mark, don't get a mark, don't get a mark, and don't get a mark. So it's 1, 2, 3, 4 marks for that. 5, 6 type A lines. 7 type B line. There you can see type B lines over there. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 divided by 2, 5.5 for, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is supposed to be 5.5 and not 10.5. Right, so there is a big mistake. There's something coming up there. All right, so we might have a problem in this case. I will sort it out and give you the marks in terms of that. All right, so, and then for the nut and the bolt, it's 5 marks over there. This is 1, 2, 3, 4. Remember, that circle must be tangentially onto the line itself. That arc over there should be tangentially on the line over there. And if it's not, if it's done by a circle stencil and it's not, it's apart from each other, then of course that will be wrong in that case. All right, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This must be on 60 degrees. This must be shown on 60 degrees. That is for the height of it and the solid line that you will find in that case over there. So that's what you will see in this regard. All right, so that is the marks for this portion over here. Like I say to you, this might change now because of this was supposed to be 5.5 and not 10.5. I will get back to you in that regard. All right, then for the right view, if I go for the right view over here, this is the right view seen from this side over here. Right view will be placed on the right hand side, so the positioning of the right view is important. Sorry, this is not where I want to go. This is where I want to go. All right, then if I go towards the base plate, which is the first portion over there, that is 4 marks. So it's 1, 2, 3, 4, 5, 6, 7, 8 marks. Remember, the angle is coming from there. The angle is coming from there. 8 divided by 2 gives you the 4 marks, which is the 4 marks over there. Then the axis, it is 1.5. Right, so if this is 1.5, remember, that is the size of the axis, and it must be solid, it must be the outside. So if it's solid, half a mark over there. If this size is 0.1 of diameter, then in that case, that is your second mark. And if it's broken, besides the size of it now, if it's broken on the inside, you're going to get another mark in that regards over there. All right, so that's for the axis. That is 1, 2, 3. It's 1.5. The base plate must be 5 millimeters. Sorry, this is messing up. The base plate itself is 5. So this is the base plate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide 2 gives you 5 marks. The wheel is 0.5. So therefore, for the wheel, it's a half a mark over there. In other words, for this half a mark that you see over here comes from the size of the wheel. If the size is wrong, then obviously it's not going to get the mark in that case. Then the nut and the washer, 3 marks. So if I go to this part over here, this is for the size of the circle, 1.5 of diameter. Right, so that's the size, a full mark for that. Now if you go 60 degrees, 90 degrees, 60 degrees, you will get 1, 2, and 3. And then for the washer, you will get another mark over there. So it's 1, 2, 3, 4, 5, 6 gives you, divide by 2 gives you 3 marks in that case. Now, this part, the technical compliance here, ladies and gentlemen, this is the more difficult part that you will find in this regard. First of all, the center lines. Now, if the learner, I do not have, maybe I can quickly open up this portion for you over here. I think it's this one over here. There we go. Now, if you should take a look at this, if you should take a look at this view over here, this is the complete view. There's center lines over here. It points out to you there's in total 12 center lines in total. All right, so where do we get them? That is 1 center line over there. That's 2. In fact, that is the 3rd center line, which is that one over there. That is 4. That is 5. That is 6 and 7. 8 and 9, 10 for the Woodruff key, 11, and 11 and 12 for that center line over there. Right, so that's your 12 center lines that you will get. Now, of course, if those center lines, 0 to 3 center lines has been showing, you don't get marks. 4 to 6, 1 mark, 7 to 9, 2 marks, and 10 to 12, that will be 3 marks in total for center lines over there. All right, title and scale, half a mark, half a mark. Sorry, I just want to get to the position, which is this one over here. Half a mark, so that gives you the marks that you can get in that regards over here on the bottom. The projection system symbol, that gives you 3 marks. It is 1 for the circle, 2 for the other circle, 3, 4, 5, 6 for the lines of the cone. Of course, if this is done on the wrong side, no marks at all. Right, so that is the 3 marks that you will get in third angle graphic projection, and then parts assembly. Ladies and gentlemen, this is the most difficult part of many of the teachers struggling in finding the correct way in interpreting this part over here. First of all, you have got an anchor, which is in this case the axis itself. All right, attached to the anchor, if the learner draw the nut separately and the washer separately and the wheel separately and all of that, he will get 0 out of 6 for the parts assembled. All right, if it is in the correct sequence, the shaft is there, so therefore we will start with that. The next option is the nut. That's 1. 2 for the washer. 3 for the wheel attaching to the washer. 4 for the Gr12 key attaching to the shaft. 5 for this bush. 6 for the bush on that side. 7 for this component that you see over here. 8 for the grip screw. 9 for the base. 10 for the collar. 11 for the pin. And 12 for that part. 12 for this part over here. Then it gives you, and I think I can make up my marks over here on this part because I only get 6 parts in total, but there's 12 marks involved. So therefore I will make up, and I think this is where the calculation come in for the mistake I've made for the grip screw, giving it 11.5 instead of 5.5. So that total will change, and I will add up my up to 11 to 12 parts over here with the marks that I will get up to that point. So I will sort this out and I will send it to you, but the understanding of the components is important. You get an axe, you get a part or parts over here, which is the anchor part. Right, in this case we will use the shaft. Right, then the nut is 1, washer 2, 3 the wheel, 4 for the Gr12 key, 5 for the bush, 6 for the bush, 7 for this part over here, 8 for the grip screw, 9 for the collar, 10 for the tapered pin, and if you go to 11, it will be the handle, which is over here. So 5 marks adding towards this part, and then of course on this part over here 5 marks will fall away. So this will total up to the correct total once we're done with this part. Okay, so ladies and gentlemen, yes, this is the memo discussion. I am done with this part over here. I thank you for listening. This is a long session, but yes, that gives you the memo discussion. For if we go to DBE for memo discussions, it takes up to 2 days, 1.5 days in sorting out the possibilities of other answers. Now, of course, you will get to your answer sheets and you will get learners that's coming up from some other areas and you don't know from what planet this learner is. So yes, you have to deal with it. You have to work with it. You've seen the transparencies. You've seen how do I work about with the transparencies. And I'm asking you to please contact me for possible questions that you don't understand. But yes, this is a thorough work through 2-hour session on the memo discussion. And I thank you for complying and also to listening to all of this up to the end. And I hope that the marking goes well. Thank you very much. Enjoy the day.